The lesson topic for this video is volume applications. So what we will be doing in this video is connecting our work with polynomials and solving them with volume problems from geometry. You will want your graphing calculator handy for this lesson. Okay, so the first example we have here is find the dimensions of the rectangular prism that will give you a volume of 75 cubic inches. So you'll notice here we have a rectangular prism, and we've got three different dimensions. We've got x plus 2 and x for the height here, and then 2x minus 1. If you think about how this x plus 2 is also the same as this and this, so this is x plus 2 here, if that is more visually understandable to you. All right, so first thing we need to do if we're going to solve this problem is we need to know the volume formula. Now you'll probably remember, I hope, that the volume formula for any prism is capital B times capital H. That's how many geometry teachers teach it, meaning that capital B is the area of the base. Okay, so whoops, that was interesting. So this B right here is the area of the base. All right, so if you think about this figure right here, the base would be this, like any of the rectangles. The rectangular prism, any of the bases could be, any of the faces, excuse me, can be the base. So if you kind of visualize this one on the bottom, now remember, it doesn't have to be the one on the bottom, that's a common misconception, but if we visualize this one down here, it is a rectangle. If it's a rectangle, then we know that the volume formula will be shifted. The capital B, the area of the base, is the base times the height of that face. Okay? All right, so again, what we'll do here is we'll fill in everything we know. So we know that the volume itself is 75 cubic inches, so we'll put 75 in for the volume. And then we know that base times height of the base, and then times the height of the prism. So this would be the length of the base, so that's x plus 2. This will be the height of that base, 2x minus 1, and then the height of the entire prism is x. Remember, another way to think about volume of a rectangular prism is just length times width times height, which is what we've done. So now, what do we do to solve this? Well, remember that application problems, level 2 problems, will be solved by using your graphing calculator. So right now, what we're going to do is we're going to just simply put the two sides of our equation into our calculator. So in your graphing calculator, you're going to put y1, you're going to put 75, and then for y2, you're going to put all of this. Remember, it's very important to include your parentheses along the way. And then once we do that, we need to solve this by finding the intersection. And there are going to be multiple places sometimes that the line at 75 on the y-axis is going to intersect our curve. So for this problem, you're going to find out that x equals 3. Okay, now let's take a look at the graph for a moment. Okay, so at first you're going to see this graph if your graphing window is the standard window, and that doesn't help us because we can't see where y1 is 75. So I adjusted my graph, and now I have this, and I'm sorry, I adjusted my window, and I adjusted my window up to y maximum of 100. So this line right here is where y1 is 75, so we can see that our curve is intersecting 75 at this point right here. So you're going to use your second intersection, or if you're on a Casio, F5, and you're going to find the intersection. And when you do that, you're going to find out that x equals 3. And remember that there is one last thing you should do to answer this problem, and that is to find the dimensions. Dimensions are what is the length, width, and height of the rectangular prism. So to do that, we're simply going to put 3 in for our different values in our picture. So if I move this here, so we've got 2x minus, whoops, sorry. We have 2x minus 1, so if we put the 3 in there, 2 times 3 is 6 minus 1, so 5 inches. And put the 3 in here, 3 plus 2 is 5, so that's our other 5 inches. And then our height is 3. So 5 by 3 by 5 or 5 by 5 by 3, I mean, it's not actually very important in this case which one goes where. Okay, so we'll go ahead and try one more of these for practice. Find the dimensions of the triangular prism that will give you a volume of 15 cubic centimeters. Now remember, a triangular prism is still a prism, so we're still going to use our volume formula for a prism, which is capital B times capital H. Okay, but this time our base is a triangle. Now this is a lot of remembering from geometry class, but remember that if we have any shape other than a rectangle in a prism, that shape must be the base. So even though it's quote unquote sitting on a rectangle, if it was laying flat on a table, that doesn't mean it's the base. The base here is a triangle. Okay, so if the base is a triangle, we need the formula for the area of a triangle. The formula for an area of a triangle is 1/2 times base times height. So we're going to go ahead and put that in. So 1/2 times base times height, and then times the other height there. So we're going to put those numbers in. If you look, well, we know the volume is 15. We're going to put that 15 in there. 1/2 times the base of the triangle, 2x plus 1, times the height of the triangle, 3x minus 2, times the height of the entire prism, which is the distance between the two triangular bases, so 2x plus 8. Okay, so we're going to have that put in like that. 1/2 times 2x plus 1 times 3x minus 2 times 2x plus 8. And again, it equals 15, our volume. So now we're going to go ahead and grab our graphing calculator again, and we're going to put 15 in for y1, and we're going to put this entire thing in for y2. Again, be careful with your fraction. You can use 0.5 there or use parentheses, and then make sure you put all of these in parentheses as well. Okay, so in front of you here now is the original graph, again, if you have a standard window, but because y1 is at 15, we can't see the intersection up here. So I adjusted my window, and my y maximum is now 20, so I can see the line at y equals 15 clearly. And you will notice that our polynomial crosses that line at 15 3 times. Once here, and once here. So what we have to make sure to do is find all of the solutions that would work for this polynomial. All right, so this one right here, and if you use second intersect, you'll find x equals 1. Okay, so x equals 1, let's think about would that work. If I put a 1 in here, 3 times 1 is 3, minus 2 is 1, so the height would be 1. 1 here, 2 times 1 is 2, plus 1 is 3, so the length would be, or the base would be 3. And then if I put a 1 in here, 2 times 1 is 2, plus 8 is 10, and 10 would be fine here. Would this point right here work? Well, that point, if you do the intersection, is -1 for the x value. So think for a minute, would -1 work? If you put a -1 here, 2 times -1 is -2, and -2 plus 8 is 6. Could the length be 6? Yes, it could. But if we put a -1 in right here, 2 times -1 is -2, and -2 plus 1 is -1. Can the length of the base be -1? No, it cannot. The same thing would happen if you found this point right here. It's going to be more negative than -1, which means it will not work for this base as well. So our answer is x equals 1. And then to find the dimensions, again, we want to put that 1 in, which we've actually already done. We put it in here, here, and here a minute ago. And so what we found out was the dimensions are 3 centimeters by 1 centimeter by 10 centimeters.